So in this second part of the trigo equation, we are going to add on the forceps. That means before even you hit the forceps, there will be some use of the trigo formula. So previously you already learned something on secant x. You already learned something on cosecant x. You also learned something on cotangent x. So right now we're going to add on one more formula for tangent x. Tangent is sine x over cosine x. Cotangent is cosine x over sine x. So if you take a look, right, there are two possible formula. So cotangent can be either this or cotangent can be either this. So sometimes you might use any one of them. Okay, and then these are the basic trigo formula that that you should already learn. So these three formulas are provided in the exam list. But what you need to know about the three formula is you can shuffle them. So what do I mean by shuffle them? So for example, this one is easily shuffleable. You can shuffle it. So what do we mean by I can shuffle it? So I can throw the cosine over. So this is a formula for sine square. I also can manipulate. If I throw the sine square over, so it will be 1 minus sine square. So this will be the formula. So I can reshuffle the formula. So you must be aware of the reshuffling of the formula and must be good with the reshuffling of the formula. Okay, so they will be presented to you in this format, but do know that they can be shuffled. So you got to get used to the shuffling of the formula. So 1 plus tangent square equal to secant square can be shuffled as well. So it can be shuffled. So I can make tangent square the subject. That will be secant square minus 1. Okay, so same thing, I can shuffle this. I can have a cotangent square. So for the first time, you will find that there's a lot of formulas. So you must be mindful about shuffling them. And actually, you will need more of this when you are doing the proving of identity. So right now, you can try to get used to it so that the next one that we'll be doing is trigo identity. We will be playing around with all these formula, same shuffling. So now we're going to have a few more technique to add on to your basic forceps. So like for example, 8. Okay, if you look at example 8, it's a bit more complex. So when you see an equation like this, okay, one thing is a lot of people will end up cancelling. So do not cancel a trigo function. So if you try to solve, you cannot cancel a trigo function. So you cannot say, okay, I'm going to cancel this. So that will be the general mistake. So this is also something like they like to filter out the students who will cancel out a trigo function. So if you don't cancel out, what do? You should bring it over and you factorize out. You take out the common factor. So it becomes, so you take out the common factor, you will end up something like first bracket equal to 0, second bracket equal to 0. So can you see first bracket equal to 0, second bracket equal to 0. After that, you execute your forceps. So for example, sine x minus 3 equals 0. If I shift the 3 over, this is what I will get. But why do I put an NA here? Because if you try to do a basic angle, you realize that your calculator will give you a math error. So that means you couldn't get a basic angle, so nothing can go on. So you couldn't go on with the 4 steps anymore. So the same thing happened, cosine x is equal to 0, you do the same basic angle. You treat cosine 0 as positive. So cosine is positive. So that's why I got the first and fourth quadrant. So I repeat the same thing for the first and fourth quadrant. So that's why I get these two answers. So all in all, I get 2 answers. Okay. So if you cancel out the trigo function, if you had cancel out the cosine x, you will lose this set of answers. So that's the effect of cancelling out a trigo function. You will lose one set of answers. So sometimes you end up losing some answers, or sometimes you end up getting extra answers. So if you're not meticulous about the range, you will end up always getting extra or less answer. Okay, and you don't know why. Okay, and then here another example where you see there's a cosine and there's a sine. So remember just now when we tried to do the 4 steps, it's meant for single trigo function. So right now I got 2 trigo. I got a sine and I got a cosine. So that's where you got to think of the formula sine x over cosine x. You got to manipulate this formula out. So how am I going to manipulate this formula out? I shuffle the 3 sine x over and I divide cosine x on both sides. Or rather, you might want to look at it this way. I divide the function over. So when I divide the function over, I'm left with the coefficient. So I divide the function over. Why do I want to divide the function over? Because it actually creates the tangent x. So initially I got 2 functions. I got sine and got cosine. But I managed to reduce it to a single trigo. So I divide over the 3, and here will be my 4 steps. Basic angle, ASTC, check the range, and then this will be my answer. So I execute in the first and third quadrant. Okay, so the 4 steps are based on single function. So where you see more than one function, there must be a formula to reduce. So the next one, we also see more than one function. You can see it's a secant and there's a cosine. There's a secant and there's a cosine. So of course, instinct is there is a formula for secant. So execute the formula for secant. And then you can cross multiply. So after you cross multiply, you will end up having a cosine square. So divide the 3 over first. Okay, remember what does cosine square means? Cosine square is a nicer version of cosine x with a square. So how do you isolate the cosine x? You actually got to take square roots. So what you will forget is, sometimes you might forget the plus minus. So eventually there's a plus minus, but does it affect your basic angle? No, because in any case, if I want to do my basic angle, I need to ignore the negative sign. So that's why if you look, my basic angle is cosine inverse of the square root. And do you realize I also get 4 answers? Why do I get 4 answers? Okay, so let's explore. Okay, in which quadrant will cosine be positive? Cosine positive will be this and this. So these two will be cosine positive, cosine positive. And these two will be cosine negative. So because of this, they have the same basic angle, but they appear in all the 4 quadrants. So that's how I get the 4 answers. Because when you take square root, there is a situation of positive and negative. Cosine can be positive. So when cosine is positive, it's first and fourth. So first and fourth. So this is first and this is fourth. And when you take square root negative, it will be second and third. So these are the second and third. So that's how you end up having 4 answers. So that will be the few main techniques that you need to know first.